Hey, today we'll be beginning Unit 3 on vector dynamics. So in grade 11, you learned about Newton's laws of motion. There's the law of inertia, F equals ma, and for every action there is an equal and opposite reaction. So in the previous unit, equilibrium, we saw what happens when the net force, F equals ma, is equal to 0. Now we'll be moving on to what happens when it no longer equals 0. So when there is an unbalanced force, it means that the system is accelerating. So here's our first example. It's asking us to calculate the sum of the two forces acting on a small boat, given that we have one vector, force 1, is 40 newtons acting to the right and 45 degrees above the x-axis. And we have a second force that's 30 newtons acting to the right, but 37 below the x-axis. So first thing we need to do is be able to draw a picture so we understand what the question is asking us. So I'm just going to draw an object so that could represent our boat. And we have two forces acting on. So we have, if I draw a dotted line, I can represent this as like some x-axis, and I have some y-axis. Acting on this, I have a force, F1, is acting at an angle 45 degrees above the x-axis. So here's some 40.0 newtons. And I have a second force, which is 37 degrees below the x-axis. And that one is 30.0 newtons. So just like what we saw in the previous units, for vectors, we have to take into account both magnitude and direction. So when we look at this one, we know this object's going to move to the right, but it's most likely also going to move upwards as well. So we need to be able to quantify both the magnitude and direction of the total net force. So how we can do this again is just like in the previous units, we're going to break down each individual vector into its x and y components. So there's F1 and F2. So just like before, we can do a little table. Here's x direction, here's y direction, here's F1, here's F2, and we're going to find out what is the overall net force in the x direction and y direction, and then combine them. So for F1, we can see that is just going to be, so F1x, that will just equal to 40.0 newtons, and we can multiply that by cosine 45 degrees. 40 cos 45. We get 28 point, I'm going to round to 3 digits, so 28.3 newtons. In the y direction, for 45 degree triangles, we know that both the x and y components are the same, so also 28.3 newtons. For F2, F2x, that is going to equal to 30.0 newtons cos 37 degrees. 30 cos 37. We get 24.0. And that's the F2y. That's going to be 30 sine 37. We get 18.1. However, to be careful here because we need to define which directions are positive directions. So I'm just going with our traditional up and to the right is positive. So F2 is going downwards. It's going to be negative 18.1. So now if I combine those, I can find my resultant force. It has an x component of 28.3 plus 24. We have 52.3 newtons. The other one we have 28.3 minus 18.1. We have a net force of 10.2 newtons up. So what this means, we're almost there. So I can draw a triangle for our net force. Our net force has an x component of 52.3 and a y component of 10.2. So we're trying to find out what is that resultant vector. So these are 52.3, 10.2. Combine them with 52.3 squared plus 10.2 squared, square root. We have a overall force of 53.3 newtons. And I need to find the angle theta. So inverse tan 10.2 divided by 52.3. We end up with 11.0 degrees above the horizontal.